Welcome you all. In this video, let us see Wade's rule. The structure of different polyhedral borohydrates were rationalized in the year 1970 by Kenneth Wade. Wade's rule allows us to predict the structure of boranes, carboranes, and other deltahedral cluster compounds. This approach is based on considering the number of BH units as a building blocks of the deltahedron, while the rest of the hydrogen of the clusters are attached as bridge entities between boron atoms. The electrons in the boranes can be counted as residual and skeletal electron. Residual electron is 2 electrons assigned to each BH unit. Skeletal electrons is the rest of the electrons in the clusters. Skeletal electrons are calculated according to the following steps. First step, we need to calculate the total number of valence electron present in the compound, counting 3 for each boron, 1 for each hydrogen, corresponding charge of the compound. Step 2, subtract the residual electron. Step 3, divide the resulting number by 2. Wade's rule is used to predict the structure of boranes. If a borane has n plus 1 skeletal electron pair, then the structure can be considered as a Closov cluster. If a borane has n plus 2 skeletal electron pairs, the structure can be considered as a Nidau cluster. If a borane has n plus 3 skeletal electron pair, the structure can be considered as a Aragno cluster. If a borane has n plus 4 skeletal electron pair, the structure can be considered as a hypocluster. We will see the examples for Closov borane, that is B6H6 2 minus is a Closov borane. So we will apply Wade's rule. Step 1 is the calculation of total number of valence electron. We have 6 boron atom, so corresponding valence electron is 18, and we have 6 hydrogen atom, so the valence electron for hydrogen is 6. Charge of the compound is -2. Total valence electron is 26. Step 2, subtract the residual electron from the total valence electron. See, when we have 6 boron atom, we have 6 BH unit. So 6 into 2 is 12. 26 minus 12 is 14. Step 3, divide the resulting number by 2. 14 by 2 is 7. We have 6 boron atoms. So n plus 1, that is 6 plus 1. We have n plus 1 skeletal electron pair. It belongs to the Closov cluster. And we will see example for Nidau borane, that is B5H9. Step 1 is the calculation of total number of valence electron. 5 boron atom we have. So 5 into 3, 15. 9 hydrogens we have. So 9 valence electron contributed by hydrogen. Total valence electron is 24. Step 2, subtract the residual electron from the total valence electron. We have 5 boron, so the number of 5 BH unit will be there. So 2 into 5 is 10. 24 minus 10 is 14. Step 3, divide the resulting number by 2. 14 by 2 is 7. Since here we have 5 boron atom, it belongs to n plus 2 skeletal electron pair. So this particular B5H9 belongs to a Nidau cluster. Example for Aragno borane, that is B4H10. Calculation of total number of valence electron. 4 boron atom we have, 12 valence electron belonging to boron, and 10 hydrogen. So we have 10 valence electron contributed by hydrogen. Total valence electron is 22. Subtract the residual electron from the total valence electron. 2 electrons assigned to each BH unit. Here we have 4 BH unit. So we have 8 electron contributed by BH units. 22 minus 8 is equal to 14. Divide the resulting number by 2. That is our step 3. So here we got 7. We have 4 boron atoms. So we have n plus 3 skeletal electron pairs. So it belongs to a arachno And example for ipoborane, that is B5H12 minus. Step 1, calculation of total number of valence electron. We have 5 boron atom, so 15 electron contributed by boron, 12 hydrogen atom, so we 12 electrons contributed by hydrogen, and the charge of the compound is minus 1. So the total valence electron is 28. Subtract the residual electron from the valence electron, that is step 2. So here we have 5 BH unit. So 10 electron contributed by BH unit. 28 minus 10 is 18. Step 3, we need to divide the number by 2. Here we got 18. So that divided by 2 is 9. So we have 5 boron atoms. So it belongs to N plus 4 skeletal electron pair. It belongs to a hypocluster. Thank you.